Today we're going to be talking about similar triangles. Now, we've learned before that two polygons with the same shape may have different sizes. Those types of polygons are called similar polygons.
He is exactly like you in every way. Except 1/8 your size.
Breathtaking. I shall call him Mini-Me.
Now, similar triangles. Two triangles are similar if each pair of corresponding angles are equal and each pair of corresponding sides are proportional. So let's focus first on the angles. You can see that angle A and angle E are equal. Angle B and angle G are equal. Angle C and angle F are equal. So also what that'll tell us is that each pair of corresponding sides are proportional. So proportional is a different word. Here what I'm going to do is focus on the side length of AB and the side length GE. If I take AB divided by GE, I will get the ratio between the two side lengths. That ratio is going to be the same as the ratio between AC and EF. And that ratio is going to be the same as BC to GF. So the first test of similarity we're going to look at is angle, angle, angle similarity. In angle, angle, angle similarity, if each of the three pairs of corresponding angles of two triangles are equal, then the two triangles are similar. This is also known as the angle, angle, angle similarity test. So here, if we have triangle A, B, C, and triangle X, Y, Z, what we could see from this diagram is that angle A is equal to angle X, angle B is equal to angle Y, and angle C is equal to angle Z. So as you're writing that down, whenever you want to show similarity, you need to write down the reasons that you know that similarity exists. So therefore, we can say that triangle ABC is similar to triangle XYZ. And because I know that to be true, I can take a look at the certain values here if I were trying to find my unknown value x. Well, I know that because they're similar, that there's a similar ratio between the two sides. So if I take BC and I divide it by YZ, I get 4/8 or 1/2, which tells me that triangle XYZ is twice as large as triangle ABC. So then if I'm trying to find my unknown, I'll know that 1/2 is equal to 1/10, telling me that that unknown side length is 5 units. Whatever that unit is, it's 5. Okay, the next test I'm going to look at is side, side, side similarity. Now, if the three pairs of corresponding sides of two triangles are in equal proportions, then the two triangles are similar. This is also known as the side, side, side similarity test. So if I want to test this out, I'm going to take a look from A to B. Should give me a similar proportion when I divide that by DE as side length BC to EF as side length AC to DF. And what I see is that all of those give me the same proportion of 3:2. So I know that these triangles are similar. And that's pretty much it for the side similarity test. It's pretty straightforward as long as you remember the proportionality. Next up is the side angle side similarity test. So here, if two pairs of corresponding sides of two triangles are in equal proportions and their included angles are equal, then the two triangles are similar. This test is known as the side angle side similarity test. So here, as I compare AC to MP, I get 80 over 120. And then I compare that to 40 over 60, which is AB over MN. I can see that they're in the same proportion. And then the included angle, so that's the angle in between the two sides, is 30 degrees. I can see that the two triangles are similar. So then I know it passes the side angle side similarity test. So those are the different types of similarity. I have two similar triangles. What I want you to do is two things. One, show that triangle PQR, show that triangle PQR is similar to triangle XYZ. And two, find the value of x. All right, have fun with that.